Hello everyone. In today's class, we'll be looking at representing forces. Forces in physics are represented using arrows. It is because force is a vector quantity, and a vector quantity has magnitude and direction. We'll talk about scalar and vector quantity in our subsequent classes. So today, we're looking at representing forces. Right. The direction of the arrow shows the direction of the force. If it is pointing northwards, it simply means that the force is towards the north. If it is towards the south, it simply means that the force is towards the south. Another thing we need to note here is that the size of the arrow shows how strong the force is. So there are two things we should take note of in representing forces using arrows. One is the direction, and two is the size. All right, have a look at this example. A box sits on a table. Describe the forces acting on the box. And what do you notice about the size and direction of these forces? Okay, just 3 seconds. All right, there are two forces acting on this box. We have an upward force and a downward force. The downward force is the box being pulled down by gravity, while the upward force is the box being pulled up by the table. So these are the two forces acting on this box that sits on a table. All right, forces always come in pairs. Forces comes in pairs, so these pairs are called interaction pairs. These forces are always the same size. Forces acting on an object are always in the same size, but they act in opposite direction. Forces acting on an object are in the same size, they act in opposite direction, and they are called action and reaction force. Let's take a look at this example here, a box on a table. Let's identify the action force and the reaction force. All right, we have a downward force and we have an upward force. The downward force, which is the force the box pushes on the table, is the action, while the force the table pushes on the box is the reaction. All right, can you look at this again? What will happen to the action force if we had a bigger box? What will happen to the action force if we had a bigger box? Okay, these are the forces acting on this box. The box pushes on the table and the table pushes on the box. So what will happen to the magnitude of the force? It gets bigger. In the same way, the action force also gets bigger. Remember, they act in opposite direction and they have the same magnitude. That takes us to some facts about force. Force always acts between two objects. Force either push the object apart or pull them together. So whenever we're talking about force, we're referring to either push or pull on an object. And this force acts on each object with equal strength, but in opposite direction. And that is the origin of Newton's third law of motion, which states that for every action, there is a reaction that is equal in size and in opposite direction. That is Newton's third law of motion. For every action, there is a reaction that is equal in size and in opposite direction. This action and reaction force. The action force has already been identified, which is the gravitational force, pulling the apple towards the earth. Remember, there must be a reaction force. And what is the reaction force? The reaction force is the gravitational force, pulling earth towards the apple. All right, have a look at this again. Action and reaction. This is a man pushing a wall. What is the action and what is the reaction? The action is the man pushing the wall. Let's assume that he's exerting 500 Newton. And what will be the reaction? The reaction is the wall pushing the man, which is still 500 Newton. You answer this question just in 60 seconds. There are no forces acting on the ball. That is option A. The only force on the ball is gravity, pulling it downwards. That's option B. The only force on the ball is the upward pull of the rope. That is option C. And option D says there are two forces on the ball, the downward pull of gravity and the upward pull of the rope. And the correct answer is option D. So please don't forget to like and share this post for others to learn. Bye.